So I'm going to tell you a little bit about reimagining food. Now, I've been interested in food for a long time. I taught myself how to cook with a bunch of big books like this. I went to chef school in France. And there is a way of the world both envisions food, the way the world writes about food and learns about food. And it's largely what you would find in these books. And it's a wonderful thing. But there's some things that have been going on since this idea of food was established. In the last 20 years, people have realized that science has a tremendous amount to do with food. In fact, understanding why cooking works requires knowing the science of cooking, some of the chemistry, some of the physics, and so forth. But that's not in any of those books. There's also a tremendous number of techniques that chefs have developed, some about new aesthetics, new approaches to food. There's a chef in Spain named Ferran Adrià. He's developed a very avant-garde cuisine. A guy in England called Heston Blumenthal. He's developed his avant-garde cuisine. None of the techniques that these people have developed in the course of the last 20 years is in any of those books. None of them are taught in cooking schools. In order to learn them, you have to go work in those restaurants. And finally, there's the old way of viewing food is the old way. And so a few years ago, 4 years ago actually, I set out to say, well, is there a way we could communicate science and technique and wonder? Is there a way we could show people food in a way they have not seen it before? So we tried, and I'll show you what we came up with. This is a picture called a cutaway. This is actually the first picture I took in the book. The idea here is to explain what happens when you steam broccoli. And this magic view allows you to see all of what's happening while the broccoli steams. Then each of the different little pieces around it explains some fact. And the hope was twofold. One is you could actually explain what happens when you steam broccoli. But the other thing is that maybe we could seduce people into stuff that was a little more technical, maybe a little bit more scientific, maybe a little bit more chefy than they otherwise would have. Because with that beautiful photo, maybe I can also package this little box here that talks about how steaming and boiling actually take different amounts of time. Steaming ought to be faster. It turns out it isn't because of something called film condensation. This explains that. Well, that first cutaway picture worked. So we said, okay, let's do some more. So here's another one. We discovered why woks are the shape they are. This shape wok doesn't work very well. This caught fire 3 times. But we had a philosophy, which is it only has to look good for 1,000th of a second. And one of our canning cutaways, once you start cutting stuff in half, you kind of get carried away. So you can see we cut the jars in half as well as the pan. And each of these text blocks explains a key thing that's going on. In this case, boiling water canning is for canning things that are already pretty acidic. You don't have to heat them up as hot as you would something you do pressure canning because bacterial spores can't grow in the acid. So this is great for pickled vegetables, which is what we're canning here. Here's our hamburger cutaway. One of our philosophies in the book is that no dish is really intrinsically any better than any other dish. So you can lavish all the same care, all the same technique on a hamburger as you would on some much more fancy dish. And if you do lavish as much technique as possible and try to make the highest quality hamburger, it gets to be a little bit involved. The New York Times ran a piece after my book was delayed, and it was called "The Wait for the 30-Hour Hamburger Just Got Longer." Because our hamburger recipe, our ultimate hamburger recipe, if you make the buns and you marinate the meat and you do all this stuff, it does take about 30 hours. Now, of course, you're not actually working the whole time. Most of the time it's kind of sitting there. The point of this cutaway is to show people a view of hamburgers they haven't seen before and to explain the physics of hamburgers and the chemistry of hamburgers. Because believe it or not, there is something to the physics and chemistry, in particular those flames underneath the burger. Most of the characteristic char-grilled taste doesn't come from the wood or the charcoal. Buying mesquite charcoal will not actually make that much difference. Mostly it comes from fat pyrolyzing or burning. So it's the fat that drips down and flares up that causes the characteristic taste. Now, you might wonder, how do we make these cutaways? And most people assume we use Photoshop. And the answer is, no, not really. We use a machine shop. And it turns out the best way to cut things in half is to actually cut them in half. So we have 2 halves of one of the best kitchens in the world. Well, we cut a $5,000 restaurant oven in half. The manufacturer said, "What would it take for you to cut one in half?" I said, "It would have to show up free." And so we showed up, we used it for a little while, we cut it in half. Now you can also see a little bit how we did some of these shots. We would glue a piece of Pyrex, or heat-resistant glass, in front. We use that a red, very high-temperature silicone to do that. The great thing is when you cut something in half, you have another half. So you photograph that in exactly the same position, and then you can substitute in, and that part does use Photoshop, just the edges. So it's very much like in a Hollywood movie where a guy flies through the air supported by wires, and then they take the wires away digitally so you're flying through the air. In most cases, though, there was no glass. Like for the hamburger, we just cut the damn barbecue. And so those coals, they kept falling off the edge. We kept having to put them back up. But again, it only has to work for thousandths of a second. The wok shot caught fire 3 times. What happens when you have your wok cut in half is the oil goes down into the fire and boom! Well, one of our cooks lost his eyebrows that way. But hey, they grow back. In addition to cutaways, we also explain physics. This is Fourier's law of heat conduction. It's a partial differential equation. We have the only cookbook in the world that has partial differential equations in it. But to make them palatable, we cut it out of a steel plate and put it in front of a fire and photographed it like this. We've got lots of little tidbits in the book. Everybody knows that your various appliances have wattage, right? But you probably don't know that much about James Watt. But now you will. We put a biography of James Watt in. Just a little couple paragraphs to explain why we call that unit of heat the watt, and where he got his inspiration. It turned out he was hired by a Scottish distillery to understand why they were burning so damn much peat to distill the whiskey. We also did a lot of calculation. I personally wrote thousands of lines of code to write this cookbook. Here's a calculation that shows how the intensity of a barbecue or other radiant heat source goes as you move away from it. So as you move vertically away from this surface, the heat falls off. As you move side to side, it moves off. That sort of horn-shaped region is what we call the sweet spot. That's the place where the heat is even to within 10%, so that's the place where you really want to cook. And it's got this funny horn-shaped thing, which, as far as I know, again, the first cookbook to ever do this. Now, it may also be the last cookbook that ever does it. And, you know, there's 2 ways you can make a product. You can do lots of market research and do focus groups and figure out what people really want, or you can just kind of go for it and make the book you want and hope other people like it. Here's a step-by-step that shows grinding hamburger. If you really want great hamburger, it turns out it makes a difference if you align the grain. And it's really simple, as you can see here. As it comes out of the grinder, you just have a little tray, and you just take it off in little passes, build it up, slice it vertically. Here's the final hamburger. This is the 30-hour hamburger. We make sort of every aspect of this burger. The lettuce has got liquid smoke infused into it. We also have things about how to make the bun. There's a mushroom ketchup. Goes on and on. Now, watch closely. This is popcorn. I'll explain it here. The popcorn is illustrating a key thing in physics. Isn't that beautiful? We have a very high-speed camera, which we had lots of fun with on the book. The key physics principle here is when water boils to steam, it expands by a factor of 1,600. That's what's happening to the water inside that popcorn, and so it's a great illustration of that. Now, I'm going to close with a video that is kind of unusual. We have a chapter on gels, and because people watch Mythbusters and CSI, I thought, well, let's put in a recipe for ballistics gelatin. Well, if you have a high-speed camera, and you have a block of ballistics gelatin lying around, pretty soon somebody does this. Now, the amazing thing here is that ballistics gelatin is supposed to mimic what happens to human flesh when you get shot. That's why you shouldn't get shot. The other amazing thing is, when this ballistics gelatin calms down, it falls back down as a nice block. Anyway, here's the book. Here it is. 2,438 pages. And they're nice big pages, too. A friend of mine complained that this was too big and too pretty to go in the kitchen, so there's a 6th volume that has washable, waterproof paper.